Hi, my name is Craig Uranic and I wanted to cover section 4.2, Rational Exponents. You can see there's only two objectives in this section. Number one is know the definition of rational exponents, and then once we know that definition, then we'll want to be able to simplify expressions that have rational exponents. Let's start with number one. Rational exponents, what are they? Well, the word rational number comes from the word ratio, which is simply a fraction. So now we will be dealing with exponents that are fractions. So therefore we'll have powers or exponents like those in example 1. Now, once we know the meaning of what a fractional exponent is, then we will be simplifying them. So let's start out by just doing example 1. So let's do example 1. You can see that there are 6 parts to example 1. And our real question, you'll notice that we have 25 to the 1/2, 64 to the 1/3. Everything is a fraction where it's 1 over something. So we're really interested in what does it mean to have a fractional exponent. That part on the bottom, what is the meaning of it? Before I explain the why, I just want to work a few problems and then I'll develop it. Part 1 of example 1 has 25 raised to the 1/2. I'm just going to give you the answer. We're going to focus on why it's the answer. 25 to the 1/2 is 5. Now the reason is because 5 squared equals 25. Or another way of saying this is we're looking for a number that times itself twice is equal to 25. So that would be 5, because 5 times 5 is 25. So let's look at part 2. 64 raised to the 1/3. Now again, we're looking for a number that times itself 3 times, in this case, is equal to 64. Turns out that number would be 4. Again, the reason that number is 4 is because 4 squared is because 4 cubed is equal to 64. Or in other words, we found a number 4, so that 4 times 4 times 4 3 times is equal to 64. So as you can see, it's kind of the inverse of taking a power. So instead of raising it to the 3rd power, it's called the root. So we're looking for the 3rd root of 64. If you look at problem number 3, it has a negative number. So it is negative 64 to the 1/3. Can you guess what the answer would be there? Again, we're looking for a number that times itself 3 times is equal to negative 64. Well, that number would be negative 4, because negative 4 times itself 3 times is negative 64. So the answer to that would be negative 4. Number 4, 16 raised to the 1/4, or in other words, the 4th root of 16. Can you guess what it would be? Good, 2. And again, it's because 2 times itself 4 times is equal to 16. Or another way of thinking of it is 2 raised to the 4th is 16. Now, I want to do part 5 and part 6 together in conjunction. Now on number 5, it has negative 16 to the 1/4. The way you should look at that is really it's saying 16 to the 1/4 and then make it opposite or negative. In other words, you could rewrite this as negative 1 times 16 to the 1/4. The book shows you a little different. So if this doesn't make sense, try looking at the book. When we are using order of operations, notice we always do exponents or powers first, and then we would do the multiplication. So 16 to the 1/4 means what number times itself 4 times is equal to 16? Well, we saw in problem 4 that was the number 2. So this is 2, so this would equal negative 1 times 2, or give us negative 2 as an answer. Now with number 6, it's literally has the negative 16 in parentheses, and therefore it's saying, what's the fourth root of negative 16? Well, that means come up with a number that multiplied by itself 4 times is a negative 16. Do you see a problem there? How are we going to multiply a number an even number of times and get a negative? If I put negative 2, then because we're multiplying a negative 4 times, we would get a positive 16. And obviously 2 doesn't work. So when we have an even root and we're trying to find the root of a negative number when this is even, then it's no solution. We can't find a number. Now you'll notice on problem 3, when it was an odd root, like negative 64 to the 1/3, we were able to find negative 2 as the answer. But in this case, it's no solution. Now that you have an idea of fractional exponents and their meaning, in other words, that they are roots, and that you're looking for a number times itself that many times to equal the original number, now that you're familiar with what that is, let's go ahead and try our hand at simplifying more complicated problems. Now that you understand rational exponents in the form of 1 over a number, we're ready to tackle a little bit more difficult problem, like problem 1 here in example 2. We know that 1 over 2 means the square root of 25, but what's up with the 3? Well, to understand and discover how we're going to use that, let's go ahead and use the properties of exponents. In other words, I can rewrite this as 25 to the 1/2 raised to the 3rd power. Now, the reason I can do that is because whenever we're raising a power to a power or an exponent to a higher power, we multiply, and we should get this. Well, notice when you multiply fractions, 1/2 times 3, you multiply the whole number times the numerator and get 3/2. Many of you are used to putting this one over the 1. So, this is the same thing. Well, now with order of operations, we could just take the square root of 25 first and then cube it. So that's what the meaning of this is. So, square root of 25 means find a number times itself twice to give me 25, which would be 5. And now cube it, which would be 5 times itself 3 times, or 125. Now, do realize a couple things. Number 1 is that we could have technically raised 25 to the 3rd power first and then taken the square root of it. However, we're trying to learn this animal and we're trying to get to know it a little bit, and so we're going to be doing these without a calculator, and 25 raised to the 3rd is a huge number, and then to find the square root of it, which is 125, would be a difficult problem by hand. So we will almost always be taking the root first. Notice another thing, which is this part of the fraction gives me the root, and this part of the fractional exponent is simply the what we are used to in an exponent or in a power, or raising it to a higher power. So, whoops, there we are. So, let's go ahead and tackle number 2. So with 2 we have a negative 27 raised to the 2/3. So again, I'm not going to split it up as I did in number 1, but we are first going to look for the cubed root of negative 27. Again, that's a number times itself 3 times to give us this. Well, that would be negative 3. Because negative 3 times itself 3 times is negative 27, but then we're going to square it. Notice I kept the negative 3 in parentheses, so we're squaring the entire thing. So negative 3 times negative 3 is positive 9. Number 3, or part 3, we have 32 raised to the negative 2/5. Well, how do we deal with the negative? Just the way we have in the past. Right now I'm going to go ahead and do the 5th root first, since that's first. Again, it's a number times itself 5 times to give me 32. Again, you will be playing around with this, and these numbers will become, hopefully, second nature to you, but it would be 2, because 2 times 2 is 4, 8, 16, 32. We would deal with this the same way we normally would. The negative exponent means I can write as a positive exponent if I put it on the denominator, and so we would end up with 1/4. Number 4, very similar. Negative 8 raised to the negative 5/3. So we need a number times itself 3 times to give us negative 8 because it's the third root, which would be negative 2 to the negative 5. Now don't let that confuse you. That doesn't mean a negative number. That means again that we can reciprocate it, take the reciprocal of it, and raise negative 2 to the positive 5th power. And negative 2 times itself 5 times is negative 32. Rather than put the negative on the bottom, I'm going to put it outside and in front of the bar. So there you have example 2. I'm going to skip example 3 because you're just substituting the exponents into a function. It's a function called the exponential function. We'll start talking about it in the next section. Right now in example 4, we're simplifying these. Again, b is always positive. And so let's just run through these real quick. We use the same exponential properties that we used in previous sections. Don't forget, when you have a number raised to a power here, you're not multiplying it times this number. 4 really has an exponent of 1, so you're really raising this 4 to the exponent of 3/2. Well, that means you want the square root of 4, and then you're going to cube it. So can you come up with the answer? Square root of 4 is 2, and then cubed is 8. So this becomes 8. Now with b to the 6th raised to the 3/2, again, the property of raising a power to a power is that you multiply. So you would multiply the 6 times 3/2. I realize a lot of people like to use cancellation, which is good, but I just want to go through what I've found easiest for students to understand. Again, multiplying a whole number times a fraction, you multiply the 6 times the 3, and then you divide by 2. So 6 times 3 is 18, divided by 2 is 9. So we would end up with b to the 9th. And that is that problem simplified. Number 2, we have fractions again. Notice they have the same denominator. We're dividing two bases that are the same and have exponents. Therefore, the rule is that we subtract. So number 2, we have b to the 2/7 over b to the negative 3/7. So again, we can just cross this off if we subtract this number. Well, since we're subtracting a negative, I'm going to convert that back to plus. And that's the rule of exponents there. So we have b to the 2/7 plus 3/7. Again, if you have the same denominator, you simply add the numerators. And because it's over 1, we don't need to put that. So b to the 5/7. Let's move on to example 5. Example 5, we're continuing to simplify expressions involving rational exponents or fractions. Our rules for exponents on part 1, of course, since they're the same base, we would simply add them. Well, this doesn't look like too difficult of a problem, only they are fractions with different denominators. So we're going to want to add 2/3 and 1/2. Well, rather than do it by hand, I think I'm just going to show you how to use your calculator. Probably the easiest way is simply to enter the fraction in and use your math key or your math function to go ahead and make it into a fraction. So I'm just going to enter in 2 divided by 3 plus 1 divided by 2, which gives me the fractions. And I Could get the answer here and then convert it from a decimal to a fraction, but I'm just going to do it right now. I'll next hit my math button, and notice right off the bat it's expecting you to be needing help with fractions, so I'll push enter here. And notice it's saying take this fraction, and when you get done, convert it into a fraction when you show me the answer. And there we have it, 7/6. So go ahead and feel free to use your calculators when you're getting these fractions that do not have the same denominator. Part 2. Now with part 2, I really wanted to cover this because students have a tendency to try to raise this whole thing to the power before simplifying what's inside parentheses. And technically, order of operations says do what's inside parentheses first. So even though I can arrive at the correct answer by raising everything to the 2/5, it's much easier to simplify first. So this would be 32b to the 2 minus 12. Well, 2 minus 12 is -10. And it's still to the 2/5. I won't write it yet. Well, because it's a -10, this would become 32 over b to the +10, and all that raised to the 2/5. Now that I'm at this point, it's real easy. I'm just going to apply the 2/5 power to 32. Well, 32 raised to the 2/5. We take the fifth root first, and we look for a number times itself 5 times it equals 32, which would be 2. And we square it, which gives us 4. With the b, don't forget, 10 gets multiplied times the 2, which gives me 20. Divided by 5 is 4. So you get 4 over b to the 4th. There you have problem number 2. The rest of the problems in this section, the example problems that is, they're basically the same as what we saw in 4.1. You're still using the same properties of exponents. However, now instead of being whole numbers, you're using rational numbers, which are going to involve fractions most of the time. So I'm not going to go over those. If you get stuck on individual problems, hopefully you can find some videos to help you do those problems, which I should have listed and given to you. If not, bring your questions to class and or email me, and maybe I can make another video. Thank you, and happy computing.